Good morning, I'm Manuel Zarzo, and today with this video I will start the Unit 6. This unit is about inference in one normal population. In this video, in particular, we'll explain the hypothesis tests. Well, what is a hypothesis test and why are they useful? They're used to decide if certain assumptions established a priori about the populations are reasonable or not. Okay? And then there are different kinds of tests. Some of them are parametric. This is if the assumption are about the parameters of the distribution. For example, the test is about the average of the population or about the standard deviation of the population. But there are other non-parametric tests if the assumptions are about other aspects. For example, like the type of distribution or independence in a table. In this unit in particular, we will only explain the parametric tests. Well, then, what is the null hypothesis? The null hypothesis will be represented as this, H0, H from hypothesis and null like a 0. Sorry. This is the one that we want to test. It's usually associated to the situation considered as correct, or usual, or desirable. Next, I will propose examples. And then we have the alternative hypothesis. It is the opposite to the null hypothesis. It's usually associated to the situation considered as incorrect, or unusual, or not desirable. Okay? And then I will try to explain this better with the following case. This is a COVID test that for sure it's familiar for you. I think that a few years ago, most of us did this kind of test to check if we were infected or not by COVID. Okay, so the null hypothesis is that the person is not infected. Okay, the correct situation, the most common situation is that we're not infected. So we make the test to know if we are infected, but the normal situation is that we're not infected. Okay. Then this is another example. In a trial or in a court, okay, when there's a judge that has to decide something, what is the null hypothesis? That the person is innocent. Okay, so by default, when a person goes to court, when he's or she's accused of something, the null hypothesis is that a person is innocent. Good. So now, thinking in an industrial process, the issue that we want to study is, can we consider that the average population length of pieces is like 350 millimeters, which is like the nominal value? Well, this is an example that appeared also in a previous video. Imagine that we have a population, we have an industrial process that is producing something. Imagine that we measure a quality parameter and the nominal value is 350. Okay, so the null hypothesis will be a parameter. That parameter can be the average or the standard deviation, or if it is an exponential about alpha. Okay, then in this case, in this example, m equals 350. The alternative hypothesis will be being different to 350. So we take a sample. This means simple random sampling. Okay, we take a sample and then imagine that the value that I get in the sample is 350.89. So based on this sample, can I say that can we reject this null hypothesis or cannot be rejected this null hypothesis? Okay, so we have so in the hypothesis test we have to decide two things. So the solution will be do not reject the null hypothesis or reject the null hypothesis. Okay. Well, reject the null hypothesis means to accept the complementary, to accept the alternative hypothesis. Well, so the opposite to reject colloquially is like to accept. But it's more, so we can say accept the null hypothesis. But if I say that, it can be confusing. Why? Because if I say the conclusion of the test is to accept the null hypothesis that m is equal to 350. So it seems that I'm saying that we have demonstrated that, that mathematically the real value of the population mean is exactly equal to 350, and this is not correct. Okay, so this is why instead of saying reject the null hypothesis and accept the null hypothesis, as it can be confusing, it is better to say reject the null hypothesis and do not reject the null hypothesis, which would mean, or which would imply that based on the information of the sample, I don't have enough information to reject the null hypothesis. Okay. So the types of hypothesis. So it can be simple hypothesis. It corresponds to a single point of the parametric space, like the null hypothesis that the population mean is exactly equal to 350. That would be an example. So assuming that this hypothesis is true, the population distribution is completely specified. Okay, then I will say, so I assume that the null hypothesis is true, and then I will say that M is exactly that value. But then we can have composite hypothesis. Composite hypothesis corresponds to a region, not to a particular value, but to a region containing more than one possible value. For example, okay, and this type of hypothesis does not specify completely the population distribution. For example, that the population mean is lower or equal to 350. Here in the first example is exactly equal, but here in the second example is lower or equal. So in this case, it's a bit more complex, but in practice, just not too much. So, and then obviously the alternative would be to be higher than. Okay. In this subject, we will only consider this type of tests, and that the population mean is equal to a value or different to that value, or that the population value is equal to a particular value or different to the value, or okay, that would be inference about one normal population, or regarding the comparison of two normal populations, the null hypothesis will be that both populations have the same average compared by different average, or that both populations have the same variance compared by versus having a different variance. This is comparison of two normal populations. Then, what happens, although this is not going to be a part of the subject, I'm just going to give rough ideas. How to study the composite hypothesis tests like this? Well, first we should test the simple hypothesis to be equal to a particular value, equal to 100 versus different to 100. Okay, and then just think with a bit of logic. So imagine that the sample mean is 104, and then the conclusion of the test is do not reject the null hypothesis. Okay, so we are saying that it makes sense to assume M approximately equal to 100. Okay, then we will lead to the conclusion do not reject the composite hypothesis M equal or lower. Okay, so if this makes sense, this is the option to choose because it contains the equal. Okay, but what happens in another case that the sample mean is 109 and imagine that the conclusion is to reject the null hypothesis? Okay, so we are rejecting this. So if this does not make sense, so we will have to accept that M is higher than 100. Okay, as we obtained a sample mean that is higher than 100, the conclusion will be that the population mean is higher than 100. But what happens if the sample mean is 92 and the conclusion of the test is to reject this null hypothesis? Well, the problem is that in this case we should say that the population mean is less than 100. But as the lower case is included in the null hypothesis, we will have to say that we cannot reject this null hypothesis because the lower case is together with the equal. Okay, so thinking with a bit of logic, these composite hypotheses are not so difficult, I would say, but anyway, we will not make this kind of exercises in this subject. Well, so construction of hypothesis tests. So one statistical hypothesis test implies that we have to establish one partition of the sample space. Okay, so the sample space is the set of all possible samples that we can obtain, and this is more or less the case. So this is the set of all possible samples. Okay, so this set of samples will lead to a region of rejection, and another group of this the complementary sample space will lead to a region of acceptance. Okay, so we will or acceptance, or better, do not a situation where we cannot reject. Okay, the region of rejection is when the sample space belongs to this region, the null hypothesis is rejected. Okay, and then the complementary region is when the null hypothesis cannot be rejected. So this means that there are only two possibilities. Okay, so this is like to make this process like a standard. So we have the sample, we have only two possibilities: reject the null hypothesis or do not reject the null hypothesis. There is no intermediate possibility. Okay, one possibility is to reject the null hypothesis or do not reject. It's important that there is like no. So from one sample in this region, this leads to reject, and all the rest of samples from the complementary region will lead to do not reject. Okay, this is important. The idea is that there are only two possibilities. Okay, there is no intermediate situation. Okay. Then, one hypothesis test is determined by the sample size. Important. For example, we take a sample of 5 individuals from the population. Also, the sample type, like simple random sampling. In this subject, we will only deal with this type of sample type, which is like the most basic one. In reality, when we have to take samples from complex population, this is not so simple, and there is a part of statistics that deals with this kind of issue. Okay, then the statistical parameter that we compute from the sample. For example, it can be like the sample mean, it can be the sample standard deviation, or there are other possibilities. And then we can compute a region of acceptance, of rejection or not rejection. Okay. For example, if the sample mean does not belong to this interval, so the hypothesis will be to reject the null hypothesis. And then, how should we test the following hypothesis? Okay, this is just to show you that there are other situations where we can also propose hypothesis tests. Imagine that we have two variables, x and y, and then we want to check if they are correlated. If they are independent, is when there's no correlation. It means that when x increases, the y does not increase. So here we will see like a cloud with any trend. So with no increasing trend and with no decreasing trend. Okay, this is when they are independent. If they are not independent, here we should see a trend. Well, so in this case, we will fit a straight line like this. B is the slope, A is the ordinate. So if they are independent, the null hypothesis is related with the slope of the line. Okay, well, this is an introduction about something that I will explain in the last unit about regression. So this is something that I will repeat again, but this is just a rough introduction. So if I want to study if x and y are independent, the key issue is the slope. If the slope is 0, okay, if I fit a straight line and the slope is 0, it means that there's no correlation, they are independent. If there is enough evidence to say that the slope is different from 0 at the population level, they will see that they are correlated. And here I finished this unit about hypothesis tests.